WCC3A. In today's video, I'll be showing you on how to demonstrate and construct the LED light visualizer effect using the Arduino. So let's get started. So as you can see here in Arduino IDE, this is our code for our activity. So in an actual, we have 12 LEDs connected into a straight line to Arduino pins 2 to 3 as an array. So these LEDs are all same type of color and they are placed close to each other so that the pattern looks continuous. So we also have push button connected to A0 on an Arduino. We use the input pull-up is mode for this button. So this means that when the button is not pressed, the pin reads high, and when the button is pressed, the pin reads low. So in the setup function, we first set all the LED pins as output and make sure they are all turned off at the beginning. We also have configured that the button pin as an input with the pull-up resistor enabled. This ensures the Arduino can detect when the button is pressed or released. So next, move to the loop function. Here, the first thing the program does is check the button state. If the button is not pressed, the pin reads high and the code executes a return statement. This immediately stops the rest of the loop from running, effectively pausing the animation. So when we press the button, the pin reads low and the program continues to run the animation. This creates a simple and pause and play control. And press means paused and press means playing. So the animation is controlled using a variable step index, which keeps track of the current step in the pattern. We use the modulo 20 to cycle through 20 steps repeatedly so the animation loops continuously. Okay, so to make the animation smooth, we use the Melius to measure time instead of delay. So this allows the Arduino to update the LEDs only after a certain interval has passed, which we call normal delay. So for certain faster phases, we use a shorter core delay. This one. The animation itself is divided into 4 distinct phases. So I made 4 phases. So the first phase is this one, the zigzag from edges toward the center. So in this phase, the LEDs on the far left and far right light up first, then the next LED inward, and so on until the animation reaches the center. So in the second phase, this one, the second phase is a bounce across the inner LEDs. Here the animation skips the outermost LEDs and moves back and forth across the inner LEDs. This creates a bouncing effect that contrasts with the edge to center motion. So here in the third phase is a rapid sweep of the middle 4 LEDs. LEDs 5, 6, 7, and 8 all return together for a few steps, then creates a bright center flash that adds emphasis to the pattern. So the fourth and final phase is at the center to side expansion. This one. In this phase, the animation is starts from the center. LEDs and lights pairs outward towards the edges. This phase uses the shorter core delay uh, to make the motion appear faster and more dramatic. So after completing all 4 phases the animation loops back to the beginning, creating a continuous dynamic light show. So this is all my code. So first I will connect the Arduino Uno, then verify it. Now after it is verified, then we should upload it, so it will run to the Arduino. So let's see. Now let's see it in action. So let's go. So guys, this is the circuit. As you can see here, the LEDs are turned off in the beginning. So this is the button, and this is the 12 LED in straight line with a 220 ohms resistor. So now let's see it in action. So when I press the button, the LEDs first connect the Arduino to the laptop. Next, when I press the button, the LEDs start moving according to the zigzag pattern. You can see them moving from edges to the center, then bouncing inside, flashing the middle LEDs, and finally expanding from the center outward. So when I release the button, the animation pauses exactly where it is. The LEDs stays in the current state until I press the button again. So this makes it very easy to control the display interactively. So as you can see, when I press the button, it continuously running. When I unpress, then it will stop to the current state. So this project demonstrates how we can combine time-led animation with user input to create an interactive light show. So the code uses clear faces, smooth timing, and a pause button that is simple but effective. So this concludes the demonstration, and thank you guys for watching.